This is Fan of Astronomy, Episode 1.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome, everybody, to the very first episode of Fan of Astronomy. My name is Angelo. I am one of the hosts on this. I'm also here with the Swedish Superman himself, or Superstar. I'm going to call you the Swedish Superstar, Mr. Dan Horning.
Thank you, Angelo. Good to be here.
Okay, so this is multiple tries to get this to work, right? And I think this time we might be onto it. Everything just keeps failing on us. I'm sorry. But you guys out there in listener land would not know any of this.
No, let's never speak of it again.
Yes. Never, ever. So, here's the deal. My name is Angelo, like I said. That is Dan. Dan is from Sweden. I am from the United States. Dan, why don't you tell them a little bit more about yourself?
All right. I'm Dan Horning, and I do a lot of podcasts and YouTube stuff. In fact, I am making a living out of it. Most of my podcasts are in Swedish. Most of my YouTube channels are not. But if you want to listen to me on an English podcast, you can find me on Fan of History, a history show I do with Brennan Rankin. And that's why we named this Fan of Astronomy. I also do a podcast about Game of Thrones called Game of Thrones Chat. So tell the listeners something about you, Angelo.
I have a question.
Okay.
Game of Thrones Chat. Do you talk book or do you talk this show?
We actually have one host that knows everything about the books. And then we have me, who have only watched the show. But we tend not to spoil stuff from the books. That is now largely becoming irrelevant. But,
yeah, it is.
Yeah.
I just wondered.
So I still haven't read the books, no.
Because the books, the last book isn't out yet. I've read the first 5.
Okay.
I've been through all them. I keep waiting for the next one, but the story's so different between the book and the show that it's kind of crazy. Anyway, my name's Angelo. I am a podcasting veteran of 5 years. I started out years ago doing a show called the Pit Imps Podcast. The first episodes were very bad, and I got pretty good at it. The last episodes were really good. But most of my past casts have been mainly centered around the game Magic the Gathering and its community. The show Pit Imps was a news show that basically went over the week's tournaments, any new releases that came out, or anything along those lines. Any, players getting banned, so on and so forth. And the Imps Prison was an interview show with people within the community. We went over literally everything, like from hockey all the way up to outer space and back to depression. I mean, we kind of bounced around everywhere. So that was an interesting show.
And that's how we kind of got to know each other. I have a YouTube channel called Magic Gathering Strat with a lot of magic stuff on it. And I did a show called the Top 10 Podcasts for Magic the Gathering. And then I found Pit Imps, and I was like, oh, another magic podcast. But there was something different about it, because Angelo tells you what he's thinking in adult language, and that was refreshing.
Yeah, I only made it up to number 4 on your charts, though. I never made it higher than that.
And number 4 was pretty high.
It was, but we kept pushing for number 3, 2, or 1, but we never could get there. We tried. But my interview show was me and a guest, while the Pit Imps podcast, I actually had co-hosts that were dedicated to the show. And we got to the point where we actually built a on-site studio to record the show in. And it did fairly well, but it was time to let it go. I don't play the game nearly as much anymore, and I had some personal things going on, and it was time to let go of it. So I quit podcasting for a while. Dan gets a hold of me. And he says, hey, I want to do this astronomy cast. And I'm like, I love astronomy. So we decided to join forces across the pond and many, many mountain ranges and try and put this thing together for you guys. It should be stated that neither of us, neither Dan nor myself, are astrophysicists. I do have some formal education in science and history, but mainly I'm self-educated. I just love those subjects.
Yeah, I'm a Master of Science in Computer Science, but I have no formal education for astronomy.
Yeah, I mean, I don't know. When we start talking about like large stars, my thermodynamics can come into it a little bit, but yeah.
Do you actually remember any of it?
I can read a thumb chart still.
Nice.
I mean, I guess that means something. I know what entropy is. That helps.
It does help.
It does. We should say real quickly, we do have a Patreon up. It is patreon.com/fan of astronomy. And what we're at.
No, just /astronomy.
Oh, just astronomy. That's right. /astronomy. Look, I get words wrong. You guys are going to realize this. I say things things that shouldn't be there, and I make things backwards, but I'm just a normal guy, so expect it. We are asking you, though, to donate like $2 an episode. Currently, we're doing 2 episodes per month, so that's $4. And there's 2 hosts here, so we're not even asking you to buy each of us a cup of coffee. We're asking you to buy one of us a really good cup of coffee a month. That's not bad.
I love coffee.
Yes, but the more you guys donate, the more you're going to get out of us. So, if you do like these shows, please help us out. And one of the ways we're going to be able to give you more is how, Dan?
Yeah, we have several goals on Patreon where you can help us achieve them. The $700 goal is that we will make this a weekly podcast. That's the big one.
Whoa!
But yeah, we will. You will have to work a lot, Angelo. But on every even 100, like 100, 200, 300, we will do a bonus episode. We have a great first bonus episode at $100, and it's about, what is it about, Angelo?
It's about how everything in the universe wants you dead.
It wants to kill you.
Everything wants to kill you. There's no way around it. Some of these are theoretical ways. Some of these are certainties.
Practical ways.
Yeah, there's a couple ways where just fact we're going to die when this happens. So we have to get off of this rock before said time, and we're going to talk about all those ways. But that's when we reach $100 in donations per episode. Not from one person. That's from, the collective of all of you. So please, spread the word about the show. Tell them to go on to Patreon. You'll get these crazy intermittent episodes, and it'll be cool. We do have... What's up?
Very short about what Patreon is, in case you don't know. Patreon is a way to sponsor stuff on the internet that has a schedule. So it's good for podcasts and YouTube shows and stuff. So it's a contract pretty much that you are saying, I will give you $2 if you make an episode, and I will give you that 2 times a month. And then if we make episodes, we get money. But if we don't make any episodes, we get nothing.
Darn. I would really like to get paid for nothing.
No, that's not the way it works.
Oh, darn it. So our next spot we're going to talk about real quick is what we expect this show to be. And I know Dan has some ways that he sees the show going forward. I have ways I see the show going forward. And if they match up, this is going to be great. If they don't match up, well, bye. Dan, what do you see this show as?
I see this show as somewhat like my Fan of History show, that we try to be entertaining, we try to be educational, but we are amateurs, and we will bring in people who are not, who can talk about astronomy. Really, we want to share our enthusiasm for this fantastic subject. Space is great. What are your thoughts?
My thoughts is, one, yes, we will be bringing in people. I already have one astrophysicist lined up to come do an episode with us right around Christmas time, so that'll probably be like a January episode, so that'll be great. But I think I want to make it easy to listen to. I don't want it to be boring like it is, when you're sitting in school and the teacher's up there barely making any money and doesn't really care, and it's just like, all right, so these are the solar system. We have the sun. And it goes out and there's 8 planets, and they're called blah, 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 blah. And you really don't care what the teacher's saying. So we want to make it a little more, invigorating than that, because, it's outer space. It's absolutely cool. There's nothing cooler than outer space in my eyes. So I want to do that. I want to find it, make it easy for everyone to listen to. I want to be welcoming to all knowledge levels. So if you don't know squadoosh about outer space, we can help you along so you'll know squat. Won't be as bad, but you'll know something. We'll bring you along. That way, we're not going to start with the most advanced stuff, obviously, because if we do that, it's really hard to soak in what we're trying to say when we're using terms you might not even know the definition to. There's things out there like Dyson spheres and ion drives and things like that. And if we don't start somewhere nice and easy, and you don't know very much about outer space, that could be very confusing to you. And I want to try to mitigate that as much as possible. We are going to have a new segment in every show. And what this basically is we're going to have our main topic. Today's is Earth. And I want to do a news segment where we talk about something from like the last 6 months that has come out about the field of astronomy. Today we're going to be talking about Proxima Centauri lowercase b, for example, which is, not close. So if you are a little advanced, the news section is where it's made for you guys who already know most of the basic stuff, but just want to keep up on what's happening in the field of astrophysics.
Yeah, we'll start the main topics going through the solar system and get some basic definitions down, and learn about things in space in our immediate neighborhood. So let's Next episode, we're going to look at the sun to get the basic idea about what a star is, and then we can talk about stars and etc.
Once we've laid down the basis of what a star is, we don't have to spend as much time on, if I say that's an M-class star, for the most part, you should know what that is after, our next episode. And there's still some freaky stars that we might have to go over time and time again, but we're going to try to mitigate as much of the boring knowledge that we've already given you from episode to episode. We should probably get into our main topic for today, and you can't start any closer to home than home. What are we talking about, Dan?
Talking about the Earth, the third rock from the sun, an amazing place, the only known place with life in the universe.
Yes, it's an outlier because we don't really know much about the universe as a whole, but for our basic known universe, which is, most of our solar system, but not quite all of it, we're not even sure where that ends. It's true. We have some neat things going on. We are in what's called a Goldilocks zone, and it sounds exactly like what it is. Not too hot, not too cold. You have to be here for life to exist. And it helps liquid water happening. We have a stabilizing moon, which, helps us from spinning too fast or too slow and keeps our wobble correct. We have a fast enough rotation that our liquid metal core creates a magnetosphere, which protects us from the deadly solar rays of the sun. It's not just the ozone that does that. I mean, the ozone layer does a lot, but without the magnetosphere, look at Mars. That's your example. Or Venus. Either one will work. They are literally hell. But
they are bad places to be.
Yes. But we have a magnetosphere, so we're good. And that's all kind of neat. There's also some other neat facts about the Earth. This is where Dan brings in all the technical crap.
Yeah, I have to talk first about other stuff that makes Earth a very good place to be. We do have plate tectonics, which is not common on planets. And plate tectonics does a lot for us. It prevents Earth being an ocean planet. It creates an uneven surface. We have plenty of water on the Earth, but 29% of the Earth's surface is land. And that's only because of plate tectonics making the Earth uneven. Otherwise, the water would be on top of everything, and that would be hard for life. We also have Jupiter hanging around a bit further out in the solar system. Jupiter is huge, and the current theory is that Jupiter does protect us. It's kind of our big brother. It bullies us a bit, sending in small rocks and stuff, but it keeps the huge dangers away from the Earth. And that's a good thing.
I would say it's a very good thing. Like, getting hit by a huge rock does not sound appetizing to me. Ask for the dinosaurs. They didn't like it.
Yeah, it happened in 1994 when a giant comet hit Jupiter very spectacularly. We are also in a pretty sweet spot in the galaxy. We are 27,000 light years from the galaxy center, so we are kind of in the suburbs of the galaxy. And it's really dangerous to be close to the galaxy center. We have supermassive black holes, we have stars forming, there are collisions, X-ray bursts, supernovas. We don't want to be there. We want to be here in the sweet suburbs of the Orion Arm. There is a hypothesis that conditions on Earth are actually so favorable that it seems unlikely they can occur anywhere else in the universe. But that's a whole episode. We're going to talk about the rare Earth hypothesis. But some basic facts about the Earth. The Earth is, strangely enough, the densest planet in the solar system. And that's really weird. And it's partly because we are 32% iron. That's 32% of the Earth is iron. You think iron is rare and valuable, but we are all iron here. And the iron is, of course, underneath the surface mostly, and that's what creates the magnetosphere. But being so dense is strange because if you look at Mercury, the first planet from the sun, it's pretty much a planet core that has been, everything outside the planet core has been blasted away, and it's still less dense than the Earth. So we have to look at another explanation why the Earth is so dense. And then I have to tell you the beginning of the Earth.
There's really stupid people here, that's why. There's just so many stupid people here.
No, our listeners are really smart, right?
Those ones are, but I mean, that still leaves a lot of people out there.
4.56 billion years ago, the solar system formed. And forming the Earth from the debris that the sun didn't suck up took about 20 million years. So 20 million years after the formation of the solar system, we had a proto-Earth cooling down, forming, starting to become a planet. But there was a problem. There was another planet called Theia, about the size of Mars that shared its orbit with the Earth. And that was not, it actually was super good for us, but at the time it was pretty disastrous because Earth and Theia collided about 10 million years later. And when Theia hit the Earth, Theia got totally destroyed and the Earth was pretty damaged as well. And this hit was a glancing blow. And if it hadn't been a glancing blow, it would have been very different today. The outer surface of the Earth got thrown into space. And after a very long time, this dust, this light stuff that was on top of the Earth, it formed into the moon, creating a unique moon. Our moon is huge and very, very light. And it's totally unique in the solar system. There are plenty of moons in the solar system, but none of them are like ours. It's so big for a planet of our size. And that has also helped us in so many ways. We already mentioned that it stabilized our orbit, but it is also protecting us from space rocks. And it is creating tides on the Earth, which is probably a prerequisite for life as well. So this was a fortunate event in the long run, but bad to be around at the time.
Yeah, and realistically, if we take that same catastrophe and we move it 2,000 miles north, we don't have a moon right now. And if we take it 2,000 miles south, we don't have a planet. So it had to hit exactly right for this to happen. I mean, like spot on exactly right. And all you have to do is just go to a pool table and hit a ball real lightly on the sides, kind of see what it does, and imagine an explosion off of it. If you hit it right at the top, the ball's barely going to move off. If you hit it just right, you're going to put just the right curve on it to go into the pocket. But if you hit that thing dead on, listen to the sound you get. It's a hard sound. And with these two planets moving at the incredible speed that they move at, hitting each other directly on, both planets are just gone. Like parts, we probably become a moon of Mars or Venus, legitimately and honestly.
Yeah. I want to give you two enormous numbers that we will work with, and we will make them simpler for you. The first is the mass of the Earth. It's 6 times 10 to the 24th kilograms. That's a lot of kilograms. And we will call that 1 Earth mass. And we will actually make use of that measure in this episode when we talk about Proxima b. So 1 Earth mass, good thing to remember. Then we have the distance to the sun. It's about 150 million kilometers. That's a pretty big distance. And we call that 1 astronomical unit. And that is also a very great measure to use for measuring distances to stars from planets. So within the solar system, an astronomical unit is a great measure to use.
It's a great measure to use because humans are arrogant and everything centers around us. So you notice that the weights depend on Earth masses where we're at, and the distance that we're going to talk about is Earth to the sun. Not the sun to Mars, not the sun to the asteroid belt. Here. Why? Because we're important. And don't you forget it.
Yeah, the Earth is great.
Yeah. I feel like saying America, but that would make no sense right now.
Sweden! We will not go into too much detail about our fantastic moon because it deserves its own episode. But the moon has been very important to cultures from the beginning of history. There's also been a search for a second moon. Other planets have second moons. Why don't we?
We should say something real quick.
Okay.
Our moon has a name.
It does.
Most common people, at least around where I live, don't know this. They just call it the moon. Why? Because that's what it is. It's the moon. Our moon's name is Luna. For anybody who doesn't know that, just figured I'd throw that out there. But we do have a second moon.
We do?
Yeah, it's kind of weird. It's 2016 HO3. And
great name.
Yes, I should just explain the names to you right now. 2016, that's the year it was discovered. HO3 are the people, the type, and the number for that year that, like that's the third thing they discovered. So that's why it gets that name.
Yeah, the third thing the HO guys discovered.
Well, it's H is the people who discovered it. I don't know who that is. The O is the type of object.
All right.
And the 3 is the third one of the year. Simple enough, right? But it's a quasi-satellite. And we call it that because it has an odd orbit, but it is a moon. And the orbit is akin to, like, if you watch racing, you know what drafting is. This thing, it is behind us for a while. It swings out, it gets in front of us, and then the Earth kind of pulls it back, and we shoot out in front of it. And when all this is happening, it gets a lot closer and a lot further away than us. And it just keeps doing that. Like they're going around a track and they just keep drafting on each other and passing. It comes as close to us as 14 million kilometers. But it's
1/10 from an AU.
Yeah, I mean, it's only 8.7 million miles. That's pretty close on a cosmic scale. But it gets as far away from us as 40 million kilometers, which is 24.8 million miles. I mean, it really does get out ahead of us and fall way behind us. But it also zips kind of close when it's making its pass to get in front of us. But this thing is tiny. And when I say tiny, I mean it's only 100 meters. It's 328 feet wide. So it's not something we're going to be, doing moon landings on anytime soon, which I should say, that's real. Get over it. That happened.
Yeah, it did happen.
Yeah. If you believe...
I was there. I wasn't.
Yeah. If you believe that the moon landing never happened, this is a good show to listen to. We're going to correct all that crap. That happened. And if you're wondering about the flag floating or, rippling in the vacuum of space, that's because of the type of pole that they had it on. It was there, and then the pole shot out at a real quick speed, and that was just a natural ripple. But it's perfectly... that will even happen in space. Okay, so those are our moons.
Don't underestimate 100-meter space rocks close to the Earth. Currently, there is no rock close to the Earth that is in danger of hitting the Earth, but once they do, it hurts. But we'll do a full episode about the near-Earth objects that are not candidates for moons or false moons.
Yeah.
So let's keep talking about the false moons.
Okay, false moons. Do you want me to go with this, or do you want to?
You can do Krithna.
Okay, so there's a famous one.
It has a name.
Yes, first I should say that there's a bunch of these. Most of them are tiny and insignificant. They're space dust. But they do kind of orbit us. And eventually, when we say a false moon, it's a moon that is captured by our gravitational pull for only a period of time, and eventually it will be leaving us. And when I say leaving us, I mean leaving us for good. Like our moon, it is slowly drifting away from us. But at some point, it's going to become perfectly locked with us, where it's going to be done moving away and it's never going to come any closer. It's just going to be stuck there. These false moons, they're going to disappear. And the most famous one is probably Krithna because it's huge. It's 3 miles wide. That's, 4.8 kilometers. That's a pretty big rock. And
almost dinosaur killing level of rock.
Yeah, if this thing hit the Earth, we'd be in trouble. A whole bunch of trouble. But what this thing is going to do is it's going to continue to make its strange orbit around us. It kind of does something like HO3 does. But at some point, it's going to leave Earth's gravitational pull and disappear. And they know this because computer simulations have shown that in 5,000 years, long after I'm gone and Dan's gone, probably you, I think.
I will be around.
You will be? Okay.
Yeah.
Well, Dan will be here, but I won't be, and I'm sure that the listeners probably won't be, but who knows? I'm going to say you're probably dead.
I will be doing Fan of Astronomy episode 50,000.
Not with me.
No, with your descendants.
My multiple descendants. But in 5,000 years, it's just going to shoot off into space, and it's going to go on its own merry way. Really, really cool thing. In our lifetime, though, for all intents and purposes, it's a moon of ours. If you have a really good satellite, you can find this thing because of its size and because of the fact that it's relatively close at times. But at the same time, you're not going to see this one with your naked eye. Like you can see you can see Luna, where you can, just look at that thing and see all the craters without even grabbing a telescope. So it's pretty cool. I know there's some satellites you want to talk about that are, false moons.
Yeah, I want to talk about a tiny near-Earth asteroid named 2006 RH120. And this rock orbits the sun every 20 years. But it has a special relationship to the Earth. Earth doesn't have a true second moon. But this thing locks into Earth orbit every 20 years for a short period where it is actually in a true Earth orbit. And this happened in September 2006 and it left us in June 2007. And it will be back. But it's only 2 to 3 meters, so it's pretty hard to look at. Yeah,
that thing's tiny, and this thing, we slingshot this thing all the way to the other side of Mercury, and it finds its way back to us. It loops around us a few times, and takes off again. And this is, it only stays for 8 months? Every 20 years?
10 months last time.
Okay, 10 months every 20 or so years. So it's a really strange thing, and it's hard to call it our moon because it goes around other planets.
Yeah, and there are 2 other rocks that have a very special relationship to the Earth that are not moons, but something entirely different. And the first is a Trojan, our only Trojan. Jupiter
condoms.
has... Sorry?
Condoms.
Jupiter has a ton of Trojans, 20 of them or something. traveling.
Yeah.
And around the Earth, there are 5 Lagrange points. These are very interesting mathematical points, but they are real close to the Earth. It's places where the gravity of the Earth, the Sun, and the Moon cancels out. So you don't have any gravity there. And one of these Lagrange points has a stone called 2010 TK7. And it's locked in a Lagrange point. It's always there. It's traveling with us around the sun, and it's always at the same distance from the Earth. Also, at some point in this show, we'll talk about aliens and life on other places in the universe. And if say there was a very advanced technological civilization in the Milky Way, and they wanted to communicate with us, if we also had achieved a sufficient level of technology, the Lagrange points would be a great place to put a message to us, because we can't reach them until we are advanced enough, and they are stable gravitationally. So if you put the message there, we'll find it once we are advanced enough.
Yeah, it should be said, these Lagrange points, there's no orbit in them. They're just there. And
yeah, of course they move around the sun with the Earth and the Moon, so it's kind of it around the sun.
But it's not like they get, there's no spin around us, or they don't wobble 1,000 miles to one side or 1,000 miles to the other side. They're where they're at, and they're stuck there.
They're incredibly stable and a great place to put satellites, except for the fact that they are quite far out for a satellite.
Yes. We're going to get more into Lagrange points when we talk about Jupiter. Like Dan said, they have upwards of I want to say it's between 23 and 27 different Lagrange points, and that's because they have so many moons, plus it's so big that it just creates a bunch of these weird spots where you just wouldn't float anywhere if you was stuck there. If you go into outer space now and say, you're on the other side of the Earth where the moon's at, you're going to slowly drift towards the Earth because of the gravitational pull. Where this thing's at, it ain't going nowhere. It's just there. So it's really cool, but we're going to get way more into this when we talk about Jupiter. We have another rock though, Dan.
Yeah, we do.
This rock is our follower. There's no real name that we can give it. It's just kind of in orbit along the exact same, it's in orbit around the sun along the exact same orbit trajectory that we're at.
It's stalking us.
Yes, it's just following us. Or we're following it. I'm going to say it's following us because we're bigger. But this is 2010 SO16. It has a very strange horseshoe orbit. It kind of swoops up it, a little bit, and then it falls back, and then it swoops up on the other side, and it falls back, and it just kind of keeps doing that. It gets a little close to us, and then it just distances away. This thing is 1,312 feet wide. That's about 400 meters. So this isn't a small rock by any stretch of the imagination. I mean, it's 4 of the HO3s that we talked about earlier. That's a quasi-satellite. So that's a fair-sized rock, and it's been stuck behind us for 250,000 years at this point. Just hanging out back there.
Tagging along.
Yeah, just, hey guys, I'm coming, and he never catches up. Poor thing. So
I want to talk about the end of the Earth.
The end of the Earth? There's too many ways.
Yeah, but if nothing really strange happens...
Well, we can talk about that when we talk about the sun.
Oh, okay.
That's a good hint.
Yeah. Next episode, the sun.
Yeah, so we're going to talk about how that thing is going to kill us.
Because it will kill us.
Eventually, yes. So, at this point, I'm going to put in a small little pre-recorded thing where, we ask you to go to our Facebook page. So, please take a listen to this. We'll be back with the news.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/Fan of Astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
Okay, so we're at the news section of the show. We're going to talk about Proxima Centauri, lowercase b.
Yes.
The lowercase is important. Why, Dan?
Because that means it's a planet, not a star.
Ooh, so a big B would mean it's a star.
Yes, the second star in the system of stars. Because most stars like to hang out with other stars, but the sun is special. It doesn't like that.
No, that we know of, but that's another show.
Oh, nemesis.
So, lowercase b, this is an exoplanet that is found in the constellation Centaurus. That's why we call it Proxima Centauri. See, naming these things is so easy. They just go, it's like playing connect the dots when you're a little kid. This, let's call it that. All right.
And Proxima means close, so it's like the close star in the Centauri sign.
Yeah, in the Centaurus sign. So very strange. But this was discovered in August of 2016, recently. And Dan, you want to give me some of the neat facts about it?
Yeah, I would do that. I have an app on my iPad which tells me whenever we discover a new exoplanet, and that app goes bing, 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 bing all the time, because we are finding tons of exoplanets right now. But we will probably never find an exoplanet that is closer to us than Proxima Centauri b. Because Proxima Centauri b orbits Proxima Centauri, which is a red dwarf star, which may be part of a three-star system. We have two sun-like stars called Alpha Centauri A and B. They are behaving nicely, orbiting each other. And then we have this little red dwarf star that is either passing by this pair of suns or it's gravitationally locked to them. But it is on our side of Alpha Centauri. So it is the closest star there is. And to get an impression of how close it is, you could consider the sun the size of a basketball here on my desk in Sweden. And then you would have Proxima Centauri, probably the size of a handball, in Brazil, in Rio de Janeiro. That's how close they are to each other. With conventional space rocket technology, like the one that took us to the moon, it would take 70,000 years to get to Proxima Centauri, which is quite a long time. But great advancements are being made in rocket technology, so that time will shorten a lot.
Considerably.
Yes.
And using conventional rocketry, there's no gas stations on the way there, is there? I mean, I haven't seen anybody put up an Exxon out of Jupiter.
No. And when you get to Jupiter, you have come like 0.001% of the way. So that wouldn't help.
And the way we get into these distances, which we're not going to get too much into it, but we slingshot off of other planets to pick up speed. That should
We'll do a whole episode on space travel.
Yes, we can do that. A whole episode. Darn, I wanted to talk about ion drive.
Okay, talk about ion drive.
Well, but you said we're going to do a whole nother episode on that.
Okay, wait with ion drive then. Let's talk about Proxima b instead.
I can do that.
This planet is pretty big because a red dwarf star is small. But this planet is bigger than the Earth. How big is it?
It's 1.27 Earth masses, so it's big.
Yeah, it's probably bigger, but that's the smallest size it can be.
Right. We are still observing this thing. Like I said, it was just discovered in August, so they're still getting more readings on it, but they know that it is at least that big, which is pretty damn big, to be honest with you.
Yeah, and when you're looking at exoplanets, you get excited when planets are like the Earth. If they are in the Goldilocks zone and they are close to Earth in size, we believe that it is more likely that they have life. And this planet is in the Goldilocks zone.
Say what?
Yes, but as Proxima Centauri is a red dwarf star, it's so small, so this is actually closer to Proxima Centauri b than Mercury is to the Sun. But that's where it's neat and warm enough if you are in the vicinity of Proxima Centauri.
Okay, we do have some problems with this planet, though.
Yeah, we do.
Possibly. And the big one is it might be completely or partially tidally locked with the sun.
That would suck.
Which means that if it's fully, one side is forever facing its sun. So there's there is spin on it, but the time that it takes for a year to elapse is the exact same time it takes for the day to elapse. Okay? So that means that one side is always facing the sun and one side is always facing out into outer space, which makes one side really hot and the other side extremely cold. That's not good for life. I mean,
that's not good at all, because you would have to live in the borderland between the night side and the day side.
That twilight zone.
Yeah, where you would have liquid water and pretty bad weather probably, if you had weather.
If you think of it on the scale of how storms happen here, where you have this high pressure system hitting a low pressure system, and storms occur from that. And when you have really big high pressure systems hitting really big low pressure systems, you get things like tornadoes and hurricanes. And this is that on the extreme times 1,000, because you have literally one side of the planet's minus 500 degrees. The other side of the planet is probably around 500 degrees because of the type of star that it is.
Wait, 500 degrees minus, that's lower than the absolute zero.
Okay,
so,
I'm talking Fahrenheit.
Okay. You Americans with your strange units.
Yes, I'm sorry. And actually, that might be too. I think it's 242.
Okay.
So, okay, we might be minus 200 on one side, plus 500 on the other side. Now, imagine where those two temperatures are going to meet, what type of storms you're going to make. I mean, we had like a few big hurricanes in our lifetime. These things would dwarf those to no end.
Yeah.
That would be awesome.
This is the way the moon is tidally locked to the Earth, because the moon always shows the same side to the Earth. But Mercury is tidally locked to the Sun in another way, creating a 3-2 spin-orbit resonance, which means that is much better if that would happen to Proxima Centauri b. So then you would have some rotation, and if you had a good enough atmosphere, you could get more even temperatures, much more favorable to life.
Much more. So much more. I mean, on mine, bacterial life is probably all we can expect.
Yeah, there are other problems, of course. Red dwarf stars live forever compared to sun-like stars. And that means that Proxima Centauri, even though it's about the same age as the sun, it's still a toddler. And it has temper tantrums, so it will blast the planet from time to time, and that's not good. Also, if you would have any sort of vegetation on Proxima Centauri b, the red dwarf star is so weak that the vegetation would have to be entirely black to do anything resembling photosynthesis.
And this is the coolest thing about this.
So imagine the black forests of Proxima Centauri b in the middle of a hurricane.
Oh, it sounds like such a bad D&D campaign. I want to do it.
The Black Forests of Proxima b.
Oh, I mean, I can just see this. Like, I mean, look, all right, I'm going to throw out a little bit of nerd cred here. I've played a lot of D&D in my life. I don't play it as often anymore, but you would enter these black forests in these D&D games, and it was supposed to be as scary as can be. Well, this is just how the animals and creatures would live on this plane, would just be black. And I mean, talk about a cool Halloween show. You stick Jason in the middle of that forest, and it quite literally makes Camp Crystal Lake seem like heaven.
Yeah, after Jason in space, you could probably do Jason on Proxima b. Friday the 13th on Proxima b.
That would be awesome.
There is a very, very small hope of life on Proxima Centauri b. And of course, as this discovery was so recent, there is a lot of work going on right now trying to figure out more things about this planet. Some scientists think that they can actually get an image of this planet as it is so close compared to other exoplanets we're looking at. Also, it's much easier to probe the planet's atmosphere, looking for oxygen, water vapor, and methane then. And that's going on right now, so there is some hope that we will know more very soon.
Yeah, probably February I would expect the next report to come out on Proxima Centauri b. We should also say that the tidally locking, that's kind of conjecture at this point. There still is the possibility that the thing spins as normal.
That would be...
Yeah, the early models show that there's more probability that it would be tidally locked in some form, but we still don't know. We don't have enough data on it to say conclusively. So it could spin as normal if that, at a normal rate. And if that happened to where there's only a 30-degree temperature drop between night and day like we have here, you could have true intelligent life on this plane. What they would look like, you got me. Because like Dan said, the plants we know are going to be black. So who knows what the animals are going to be, because they tend to take after their environment.
Klingons.
Yeah, so you would expect them to be one very dark and just who knows what, because it's so much bigger. That means that they'd probably be shorter because of the gravitational pull of this plane. And there's just so much cool stuff going on with this that we could have real life this close to us. And
so Hobbit Ninjas?
Ninjas? Hobbit Ninjas. Hobbit Ninjas. That sounds
and they're amazing. Black and they're small.
That sounds utterly amazing to me. I want a Hobbit Ninja for Christmas. But yeah, the reports that tend to come out through the science journals, they're usually every 6 months on a very specific subject, because certain groups of scientists get access to certain telescopes and what have you for periods of time, and then it takes them a little bit of time to compile that data, and then they put that data out, and that's when we find out about it. They probably are going to get their next data return between probably before Christmas, I would think. And then they'll take a month or so to compile the data and then let us know what they found. If anything cool pops up, we will absolutely let you know.
If we are going to get really far out, there is a small chance that we can visit Proxima B within our lifetimes.
That would take some work.
Yes, and it's called Breakthrough Starshot. It's an idea that has been around before the discovery of Proxima B, but Proxima B turned out to be the perfect target for it. It's a research company called Breakthrough Initiative, sponsored by some Russian billionaire. And it's a fleet of miniature unmanned spacecraft called starships. They are really small, like a baseball.
Something like
that. Maybe smaller than that. With like a sail and a camera. And they would travel. You didn't get to talk about ion drives.
Oh, now I do.
Yeah. So tell them how they would travel.
They travel by ion propulsion, which is basically they have these sails, kind of like what you'd see on a ship in the ocean, 100 years ago. Or even now, actually, because I guess there is still sail ships. I don't know why I said 100 years ago. Anyway, but what these things do is they capture ions. These ions are shooting off of the sun at light speed. And they capture them, and these things push the craft forward. Now, here's the thing with the ion drive. It does slow down these ions. So you can't quite go at the speed of the light, but that would be a good thing. Because if you go at the speed of the light, you become light. And then putting you back together isn't easy at that point. I don't think it's possible, actually. So what they'll do is it'll push this thing. The sail will slightly slow down the ions, and it'll push it almost at the speed of light to this thing. And when I say almost, that's relative as well. But it's a lot faster than any chemical technology that we have now could possibly push anything.
The theory is that this small fleet of starships, maybe 1,000 of them, you send off 1,000 because you want some to reach the target. And they would then theoretically be able to achieve a speed of 20% the speed of light, meaning they could get to Proxima B in 20 years. And then they will take photographs, they will orbit, and we would get news then 4.2 years later, because that's how long it takes for light to get to Proxima B.
Yeah, I mean, it's really cool. The scientists would get that information in 4.2 years. We wouldn't.
No.
We would get it in 4.5 to 5. But, I mean, this is the future of space travel as far as we can tell right now. I mean, we're nowhere near folding space yet. And that's its own episode. So, I mean, this is probably the quickest way we have in the foreseeable future is ion drive technology. And the problem even with that is you still have to get it off of the Earth to make it work. So a lot of chemical power is still being put into this thing to get it off of the Earth. But once it's up there and you have no gravitational pull, no wind, nothing like that, all of a sudden these ions can really speed something up. So, can you think of any other things that Proxima might mean for us? Oh, wait. I can think of something. When this rock that we're on is going down, and it's going to happen, that is the most likely rock we're going to go to.
We can move to the Black Forests.
Yes, I mean, if you really think about it, if we're running out of time on this planet, that is the closest planet that might be able to support us. We don't know nothing about its atmosphere or anything, but which we should get that information soon, I think. I mean, that's the closest we got that could possibly do it. So that's why it's so important for us to look at these exoplanets and to try to find ones in the Goldilocks zone. Preferably, we'd want them to have life, but if they don't have life, that's not necessarily a bad thing either, because they could have life when we get there.
Yeah, and we're not going to find a closer exoplanet. There is some indication that there is another planet around Proxima B, but it is not proven yet, and it would not be as good a near-Earth candidate as Proxima B.
Right. So, if you're listening to this on iTunes, please go ahead, go to the iTunes page. Please give us the 5 stars, write us a review, help us climb the charts so more people can get their eyes and ears on this show. We want that to happen. If you're listening on YouTube, please go ahead, hit that like button, hit that subscribe button, let your friends know about it, and we will very much, very, very, very much appreciate that. We will read one iTunes review per episode as long as we get one iTunes review an episode. We're also going to answer questions that come via email or through the Patreon. Preference will be given to patrons because they're helping support the show. We kind of have to throw it back to them a little bit. But if you send us an email at aofcast@gmail.com, that's aofcast because I'm an idiot. Just bear with me on that.
So it's Astronomy of Fans.
Yes, astronomyofanscast@gmail.com. If it's a really good question, we will give that preference over a patron. Obviously, we want to answer the best questions every episode, but we will be looking at the patron questions first. No ifs, ands, or buts about that. We'll also thank any new patrons we get each week. So if you give the $2, your name will be said on the air, and we will be thanking you, like children. Oh, thank you for sending us money. We appreciate it so much.
I need coffee.
Yes, we need coffee. We're going to fight over who gets the good coffee and who gets the gas station tar, but one of us will get coffee. Okay. So if you wanted to get a hold of me, though, directly, you can get a hold of me at FOA Angelo on Twitter. That's a great place to get a hold of me. I will be going ahead and basically retweeting a bunch of science articles and occasionally giving my opinion on some of these things. And it's a very science-centered Twitter page. However, I do have another Twitter page, which I'm not going to give out the address, but it's not family-friendly at all. So if for some reason you wanted to talk to me on that one, just get a hold of me on the FOA one, and I will give you the other address. You can also get a hold of me on our Facebook page, which is facebook.com/Fan of Astronomy, right?
Yeah.
Okay. And there, again, I post a lot of science articles. Dan posts a lot of science articles. We're always there to chat with you guys if you have any questions. Anything else that they can do on there that I could think that's just slipping my mind?
No, you should also check out our YouTube channel if you haven't yet. It's Fan of Astronomy on YouTube. Just search YouTube for Fan of Astronomy. You can tweet to me at Dan Horning. I keep one Twitter for everything, and it's family friendly. Except it has a lot of stuff on murder on it because of my Swedish murder podcasts. But you won't understand that, so that's safe.
I guess that's safe. But if they're Swedish, it's not safe.
No, Swedish is really safe.
But they'd understand it.
True.
So it might not be, I don't know. Look, I'm just rambling at this point. So we're going to call this an episode. I hope you guys enjoyed our very first one. So on behalf of myself and Dan, keep in mind that space is always very interesting. It constantly surprises us, and you should keep looking towards it.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out and throw them a couple bucks an episode. They will really appreciate it. Thanks.